E4 Computer Engineering is an Italian company founded in 2002 and based in the Emilia-Romagna region, the Italian Data Valley. The company is a solution provider for high-performance computing, artificial intelligence, and cloud computing. At E4, we are very mindful with respect to new technologies, which we propose to partners and customers. Among our customers, we see organizations such as CERN, the European Centre for Medium Weather Forecast, Cineca, and Leonardo. Since 2013, we are partners of several European projects. One of these projects is Textarossa, the project I would like to talk to you about today. Textarossa is a project financed by Euro-HPC joint undertaking in 2021 of the duration of 3 years. The aim of the project is to develop core technologies for computing architectures towards exascale class systems. The project is led by the Italian Research Center ENEA, and besides ENEA and E4, it involves 9 Italian and European partners. One of the core technologies developed by the project addresses a key challenge in HPC, the so-called cooling problem. Novel HPC components are power-hungry. Traditional cooling solutions are not sufficient to dissipate the heat produced by future generations of HPC systems. Textarossa tackled this challenge by realizing an innovative two-phase cooling system. A liquid is sent to cool the different HPC components. While it removes the heat, the liquid changes phase and evaporates. In this way, we leverage the latent heat of the liquid as opposed to the sensible heat without phase changing. The former, the latent heat, is much more efficient than the latter, the sensible heat, and therefore we can remove more heat with the same flow rate and pumping power. As a consequence, we expect that the two-phase cooling system enable a 20% reduction in energy consumption compared to a conventional liquid cooling system. It is curious to note that this is the same technology used to cool down nuclear reactors and some European Space Agency applications. The big innovation of Textarossa is the miniaturization of this technology, such that to make it suitable for cooling down small objects like the components of an HPC system. The coolant used in Textarossa is peculiar and covered by a patent. It is a dielectric fluid. This means that even in case of a leakage, there will be no damage to the hardware. It is non-flammable and not toxic. At the end of the circuit, there is a condenser where the evaporating fluid exchanges heat with a liquid or with air and returns in a liquid phase. At this point, the fluid is sent back to cool down the electronic chips. The innovative two-phase cooling system was designed by Textarossa partner In4. Within the project Textarossa, the two-phase cooling system was applied to 2 innovative machines called Integrated Development Vehicle A, or IDVA, and Integrated Development Vehicle E, or IDVE. These are 2 one-node prototypes which could pave the way to exascale systems. IDVA was developed by Textarossa partner Eviden. It features 2 CPUs Intel Sapphire Rapids, each with a thermal design power of 350 Watt, and 4 GPU NVIDIA Hopper, each with a thermal design power of 700 Watt. Just for comparison, 350 Watt is the typical power of a microwave oven or a vacuum cleaner, while 700 Watt is the typical power of an air dryer. In a pre-exascale or exascale HPC system, there will be more than 4,000 such nodes, with a power consumption of the order of megawatt, similarly to a small city. Our company, E4 Computer Engineering, developed the other innovative machine, IDVE. Our machine features 2 Ampere Ultramax processors, each with 128 physical cores. The Ampere Ultramax is an interesting CPU because it is not based on common x86 architecture, but ARM, in particular ARM version 8.2, Neoverse N1. ARM is the CPU that commonly powers smartphones. In recent years, it started to be employed also in the HPC sectors, where, for instance, it is used in the Japanese supercomputer Fugaku, the world's fastest supercomputer from 2020 to 2022. As accelerator, IDVE contains 2 FPGA AMD Alveo U280. All these components, together with 4 banks of DDR4 RAM, are contained in a conventional 2U Monte Collins server about 33 inches long, 19 inches large, and 3.5 inches tall. The server has enough space also to accommodate PCI Express card and disks to save data and a two-phase cooling system. The cooling circuit is split in two branches after the condenser. Each branch cools down a CPU, a FPGA, and two banks of RAM. The CPU and the accelerator of IDVE have a thermal design power of 225 Watt. The power consumption of IDVE is less than that of IDVA. Therefore, the two machines work in different thermodynamic regimes, and it will be interesting to understand where the two-phase cooling will be more performant. The innovative two-phase cooling system is now available in our catalog. We are now in the final phase of the Textarossa project. The different partners are testing their IPs and applications on IDVA and IDVE. Watch their video to find out more about the cool results of the Textarossa project.